Assalamualaikum and hi to my fellow judges. Before I'm started, let me introduce myself. My name is Nur Shahira Bintu Zulkifli. I'm from UC Tete Malaysia and category the MPI of category A. Okay, so today I would like to present for my research director of the research is Centroidal Polygon, a new modified Euler to improve speed of resistor-capacitor RC circuit equation. Now we go to the introduction. In introduction, I will discuss about the Euler method, the new scheme that will be used, and the first order RC circuit equation. As we know, Euler method is one of the oldest and simplest method in numerical method to solve the mathematical problem. However, Euler method is lacking of accuracy compared to other methods such as Roche-Filter and Enderby-Ford. The fundamental laws of physics, mechanics, electricity, and thermodynamics are usually based on the empirical observation that explain variations in physical properties and state of system. The differential equation is an unknown function and derivative will be composed when the function involved in one independent variable. The equation called is ordinary differential equation. T is classified as to the order, such as first order equation are referred to the highest derivative is a first derivative, second order equation would include the second derivative. The new scheme that will be created to solve the first order and RC circuit equation. I use determine as my main mean of create to the new scheme by combining mean and Euler. Centroidal is one of the simple concepts that use any two positive real numbers center of an object refer to its geometry. It is very useful concept in engineering to find the center of an object and other application. This proposed scheme will be applied in first order ODE and first order RC circuit equation. As we test in first order ODE, I choose resistor-capacitor equation to be applied in my new scheme. So the RC circuit equation they have two conditions which are charging and discharging condition. So the new scheme will be focused on the speed, and when it's successful test, the new scheme will be compared with the existing scheme such as Polygon scheme by Zozamri, harmonic polygon by Noharfiza, and cube polygon by Noraida. Now we go to the problem statement. As we know, Euler method is used to generate a simple numerical solution and promise a low-cost implementation applied to first-order RC circuit equation and first-order ODE. So because of that, these are the problems that we will discuss. First, the step size, second, error, and last, the speed. For the step size, by referring from previous research, it shows that Euler method only can solve the problem of the equation in small step size only. However, small step size is computationally expensive, where in large step size, the solution is not accurate and the solution is unsatisfactory. Second problem is the error. They have two of an error in this problem, which are error in Euler and in RC circuit. In Euler, the less accurate is come from the larger error that need to generate in each loop. In RC circuit equation, the error from the old method of analyzing electrical circuits such as stopwatch voltmeter will make the analysis prone to human error. And the last problem is for the speed. In the previous research, this take the long to complete the simulate. For this new scheme, I will be create the speedy result will achieve fast, fully charged, and fully discharged. Now we go to the objective. They have three objectives they need to achieve. First, to propose the new scheme by enhanced Euler method by setting the mean. Second, to test the enhanced Euler method can solve the first order circuit equation, RC circuit equation. And third, to analyze the speed in terms of time taken to complete the simulate in each scheme. Now we go to the methodology. The framework discusses the plan and how the research is to be conducted. There are three phases to create a new scheme until the solution for electric circuit equation. Okay, now we go to the phase 1. In the phase 1, the researcher will create an initial idea from the previous research that use the same solution, and then when it's have an idea, the researcher go to the phase 2 to create a new scheme and we test into the Scilab software. Until it is successful, the new scheme will be tested at the phase 3 by using the test into the RC circuit equation. When it's successful test into the RC circuit equation, the new scheme will be compared with other methods such as polygon, harmonic polygon, and cube polygon, and will be also developed into the Scilab software. Now we go to the equation. In Euler method, they are used produce two main methods to improve Euler, which are Hill method and midpoint method. So in my research, I use midpoint method as my main method to improve by using a new scheme. In this method, also called as improved polygon. This method uses Euler method to predict a value of y at the midpoint of the interval. And by using the equation, this predict value is used to calculate the gradient at the midpoint. Midpoint method is superior to Euler method because it utilizes slope estimate at the midpoint of the prediction interval. by using the midpoint method. I apply in my new scheme in combination of Euler method and mean concept. I have three-step combination which are equation of Euler method and mean with using centroidal mean equation. The general formula for centroidal mean is a squared plus a 2 times a squared plus ab plus b squared divided to 3 times the a plus b. Centroidal scheme will be formed by using function in Euler change to the new scheme that we will propose, and the combination called as a centroidal polygon. Now we go to the RC circuit equation. When it is charged, the charge condition is when the switch is closed in position B for a long time, allow the capacitor to have no charge. At time t equal to 0, the switch is relocated to position A and the capacitor charge. Yet the discharge condition is when the switch is closed in position A for a long time and switch to point B when t equal to 0. All the equations are derived from the Kirchhoff first law. This research will focus on the charging and discharging condition with the three difference of circuit. This is the list of equations. Before I'm tested into the first order RC circuit equation, the new scheme will be tested into the first order ODE in two conditions which are linear and nonlinear equation. When it's successful, the new scheme will be tested into the first order RC circuit equation which are two conditions, charging and discharging condition. This is a result that will be recorded that will be compared with the centroidal polygon. Compare the result between the polygon, harmonic polygon, and cube polygon. This is the video for my demonstration for the charging test and discharging test. In the discussion, we will discuss that the new scheme can be applied in first order RC circuit equation, and the new scheme more faster to simulate in all step size 0.1, 0.01, and 0.001, and the new scheme more faster in both conditions in charging and discharging condition. This is my result. It shows that the centroidal polygon will more fast at the all step size at the circuit 1, circuit 2, and circuit 3. This is my achievement. I already present at the Retreat 2020 and Tamina, and I already published one journal. The title of the journal is Centroidal Polygon Solving First Order Ordinary Equation using Centroidal Mean to Improve Euler Method. This is my reference. Thank you.